Hello everyone. So today we're going to solve this problem. Given positive real numbers a, b, and c, show that a cubed over b plus b cubed over c plus c cubed over a is greater than or equal to ab plus bc plus ca. So in order to solve this, we're going to have to use a technique with the AM-GM inequality. So the AM-GM inequality states that the arithmetic mean of a set of non-negative real numbers is greater than or equal to its geometric mean. So we're going to use the AM-GM inequality in order to show that this inequality holds. So what I'm going to do is I'm going to use the first term only, so a cubed over b, and I'm going to add it to ab. So I'm going to take the arithmetic mean of this, so it's 1/2. So this is greater than or equal to the square root of their product. So a cubed over b times ab. So this is by the AM-GM inequality. So I'm doing this because I want the b's to cancel, and in the right hand side it will become a squared. So further simplifying this, it will be a cubed over b plus ab, which is greater than or equal to 2a squared, because this becomes the square root of a to the 4th power, so it's a squared. And then I just multiplied by 2 both sides. So I'm going to do the same thing with the second term, b cubed over c, which is here. And I'm going to do the same thing basically. So I'm going to take the arithmetic mean with bc and its geometric mean. And this further simplifies to b cubed over c plus bc, which is greater than or equal to 2b squared. And lastly, I'm going to use the third term, which is c cubed over a plus ca. And this simplifies to c cubed over a plus ca is greater than or equal to 2c squared. So now we have these three inequalities. So I'm going to denote this as inequality 1, inequality 2, inequality 3. So combining the three inequalities, so inequality 1, 2, and 3, so we're just going to add. So this becomes a cubed over b plus ab plus b cubed over c plus bc plus c cubed over a plus ca, which is greater than or equal to 2 times a squared plus 2b squared plus 2c squared. So I'm going to group this a little bit. So this becomes a cubed over b plus b cubed over c plus c cubed over a plus ab plus bc plus ca, which is greater than or equal to 2 times a squared plus b squared plus c squared. That looks a little cleaner. Now what I'm going to do is I'm going to try to get something out of this a squared plus b squared plus c squared term. So we're going to use the AM-GM inequality again. So what I'm going to do is I'm going to take the arithmetic mean of a squared plus b squared, which is greater than or equal to its geometric mean. So this further simplifies to a squared plus b squared, which is greater than or equal to 2ab. And we're going to do the same thing with b squared plus c squared. So the this becomes b squared plus c squared greater than or equal to 2bc. And lastly, we have a squared plus c squared, which becomes a squared plus c squared greater than or equal to 2ca. Now, I'm gonna denote this whole inequality as inequality 4, this one as inequality 5, 6, and 7. Now, I'm gonna combine 5, 6, and 7. So, combining the inequality 5, 6, and 7. So, this becomes 2 times a squared plus b squared plus c squared greater than or equal to 2 times ab plus bc plus ca. So I'm gonna call this equation or inequality 8. Now we can see that 2 times the quantity a squared plus b squared plus c squared appears on the right hand side of inequality 4, so here, which is less than or equal to this whole thing. And we can also see this 2 times a squared plus b squared plus c squared in the left hand side of inequality 8. So we can combine the two inequalities once again, or like compare them. So combining 4 and 8. So this obviously must be greater than this. So now the whole thing becomes a cubed over b plus b cubed over c plus c cubed over a plus ab plus bc plus ca, which is greater than or equal to 2 times ab plus bc plus ca. And now we can subtract ab plus bc plus ca because we have common terms, and this will become a cubed over b plus b cubed over c plus c cubed over a greater than or equal to ab plus bc plus ca. And this is the original inequality we're trying to show. So we're done.